Okay, everybody, so I'm going to go ahead and solve these problems for you. Hopefully you were able to get through most of them. All right, so starting off, remember I like to do my little column thing here. Okay, so on this side, I'm going to list out P, V, N, R, T, and we know that R is always 0.0821. Okay, and remember, let's look for P. P is right here. It needs to be in atmospheres, and it is in atmospheres. 1.2 atm. Volume is right here, and it is not in atmospheres. It is in milliliters. So we need to convert that to liters by dividing by 1,000. So we have 0.890 liters. Moles is what they're asking us for. Okay, so that's going to be that. And the unit on the answer is going to be moles. And temperature, 21 degrees Celsius. So that is not in the correct unit. 21 degrees Celsius, we need to add 273. So add 273 to 21, that's going to be 294 Kelvin. Okay, so then we go up here and we look at our equation, PV equals nRT. They're asking for moles, so we need to isolate moles by dividing both sides by RT. So N is going to be equal to PV divided by RT. P is 1.2. V is 0.89. R is 0.0821. And T is 294. Remember, that needs to be that absolute scale of Kelvin. And I got my answer, and that answer is 0.04 moles. Again, round however you want, just to make it look nice. All right, number 7. At what Celsius temperatures? Remember, at the end here, we're going to subtract out 273. Okay. Will 0.0654 moles of neon gas? Oh, it's all the same stuff. So P, V, N, R, T. I'm just going to go through and look for each variable. So there's P, 1.95. They gave it to me. There's V, 12.3 liters, atmospheres. N, there it is, 0.654. We know R, 0.0821, and we're looking for this. Now remember, they're asking for Celsius. Again, pressure is in atmospheres, volume is in liters, moles is in moles. We don't need to do any strange conversions. They're looking for temperature, so temperature is being multiplied by nR. So how do we undo that? By division. So T equals PV over nR. That's going to be 1.95 multiplied by 12.30 liters, 0.0821, and N 0.654. That should have been on the other side. Sorry about that. Okay, so pause this. You're going to get 452.8. But remember, that's Kelvin. Okay, so if degrees Celsius plus 273 equals Kelvin, that means degrees Celsius equals Kelvin minus 273. So that number minus 273 is about 180. So it's around 180 degrees Celsius. Come on, there you go, buddy. All right. So in number 8, determine the number of grams, right? It's all the same stuff though. So let's go ahead and do the problem. Okay, so P, V, N, R, T. Determine the number of grams of carbon dioxide. So first off, when they say grams, what they're really looking for is moles. Okay, so we are going to get our answer in grams, and then we're going to have to convert that answer to moles at the end, just as a heads up. Okay, in a 450.6 milliliter tank, okay, so that's 450.6 milliliters divided by 1,000 equals 0.4506 liters. Okay, at 1.8 atmospheres. And we know that this is 0.0821. And negative 50.5. So remember, really showing you why we need Kelvin. If we put a negative into PV equals nRT, everything would be negative. So let's go ahead and add 273 right on there quick. So negative 50.5, negative 50.5 plus 273 equals 22.5. So 222.5 Kelvin. Okay. All right. So we're solving for n. Then we're going to convert to well, this is deceiving. So we're going to get moles, and then we're going to convert to grams. So this is actually the answer you're going to find, and then we're going to convert there. Because remember, if PV equals nRT, okay, then N equals PV over RT. Okay, N is moles, so 1.86, and moles is always the route to grams. 0.4506. R is 0.0821. Okay, and temperature is 222.5. Okay, I'll get that answer for you. Got our answer here, and the answer is it's around 0.05 moles. Okay, something around there. Okay. So we have 0.05 moles. Now the first problem said, well, how many grams of O2 would be? Well, actually, the first problem said, how many grams of carbon dioxide would that be? So I'm going to go over here and do this problem down here, okay? So the first one is grams of CO2. Okay, so if they want grams of CO2, we know that the molar mass of CO2 is 44 grams per every 1 mole. Okay, and they want X grams if we had 0.05 moles. So we would cross multiply, and that answer would be 0.05 times 44 is 2.2 grams of CO2. Okay, so if you had 0.04 moles, 0.05 moles of some ideal gas, and that gas were carbon dioxide, that would be 44 grams. Okay. Now, if you had the same number of moles of a lighter gas, oxygen, we should assume that we're going to have less grams. So then the question says, okay, well now you got 0.05 moles. That's a random value. You applied that to CO2. Now apply that to O2. So we know that O2 is 32 grams in every 1 mole. X grams over this 0.05 moles. Remember, N is moles. It's not mass. N is the amount. Well, you have the same amount of a smaller thing. So we're going to get a smaller overall mass. 0.05 times 32 is 1.6 grams of O2. O2 is a more ideal gas because of this. So you have the same number of moles. When applied to carbon dioxide, that amount had a mass of 2.2 grams. When applied to oxygen, that amount had a mass of 1.6 grams. So now that we're moving on here, though, to this next problem, I'm just going to go ahead and erase this stuff. So you guys can always just rewind the video if you need that, okay? All right, let's go ahead and do this problem. Let's do it the same way we've done everything else. We have P, V, N, R, T. Find the volume in milliliters, okay? So again, it's gonna come out in liters, okay? And then we're gonna have to convert it to milliliters. So it's gonna come out in liters, and then we're gonna do a little conversion to milliliters at the end, okay? If 7 grams of oxygen and 1.5 grams of chlorine are mixed in a container, all right? So this is going to give us the mole value, Okay, so all we have to do here is convert each of these to moles and add them up. We'll do that in a moment, okay? But let's write that here. So 7 grams of O2 plus 1.50 grams of Cl2. Now we can't add them up right now because we don't know how many there are of each of them. Remember, the mole value gives us the amount. So we're going to convert each of these to moles, to N and to N, and then we're going to add up the N's, and that's going to give us the total N. And they said it's at 482 atmospheres. All right, that's cool. And then, let's see, 22 degrees Celsius. So 22 degrees Celsius, we're going to have to add 273. So we know when we do that, that should be 295. 295. Okay. So let's go here and let's do the mole conversions over here on this side first. All right. So what do we got here? Well, we got 7 grams of O2. So we know that O2 is 32 grams per 1 mole. 7 grams per every X moles. Okay. So how many moles of O2 is that? We're going to have to cross multiply. 32x equals 7. So 7 divided by 32. Okay, that's going to be 0.22. Now you guys can round it. So this is 0.22 moles of O2. Okay, so that's our first mole value. Okay, and then we have 1.5 grams of chlorine gas. Okay, so chlorine gas, if you look on the periodic table, has a molar mass, I believe, of, let me ask Siri. Siri, what is the molar mass of chlorine gas?
The answer I found is 35.451 atomic mass units.
Okay, so we're going to double that. So it's about 71 grams of chlorine per every 1 mole equals, and now we have 1.5 grams per X moles. Okay, so how many moles of chlorine? Well, chlorine's a heavy gas. So we're going to go ahead and cross multiply. 71 times X equals 1.5. So 1.5 divided by 71 is 0.02 moles. So now we have to add that, and we get 0.24. So the value for the mole value, the value here, is 0.24. So now let's go through and find the volume in milliliters. So if PV equals nRT divided both by P, V equals nRT over P. Okay, we know that N is 0.24. We know that R is 0.0821. We know that T is 295. And we're going to divide that all by 482. I got is 0.01 liters. All right, but remember, we want the answer in milliliters. So I got to multiply that by 1,000 times 1,000, and I get 12.1 milliliters. That's our answer. All right, last problem here. And this is a really, really, really good problem. So I'm going to up here outline sort of what you're going to do in this problem, and then we'll solve it down here. Okay. So 500 liters of a gas are prepared at 7. You know, actually, to be honest with you, I'm going to have you skip this problem because I've done nothing with millimeters of mercury, which is another pressure unit, with you guys. But if you wanted to do this problem, there's a conversion from millimeters of mercury to atmospheres, okay? And what you would do in one problem here, notice that they give you volume, they give you pressure, and they give you temperature. Okay, so you would use that to solve for moles, and then you would put that mole value in the other problem, and then find the new volume once it was cooled. So there's this connection between the two problems where you have PV equals nRT. You're going to find N, and then you're going to plug it into V equals nRT over P to find that new V.